Next application of divide and conquer is selection procedure, right? I written on the board also, please read it. Input, an array of n elements and integer k. Output, return position of the kth smallest element. This is the input and output. Return position of the kth smallest element. Right? How to do that I will explain now. Can you help me now? To solve this problem one way. Please give answer. What is the answer to this problem? If array already sorted. In this problem array not sorted, that is okay. Right? To this problem, what is the answer if array already sorted? If array already sorted in the ascending order, if the array index is starting from 1, array is already started from, array index is already starting from 1 and array is in the ascending order, then what is the answer? How to find out kth smallest element? Return a of k. Array name is a, assume that, return a of k. If array sorted, kth smallest element finding, return a of k. Right? Please be careful. So, can you help me now to this problem? What will be the time complexity if array sorted? Answer is constant time. Next one. To this problem, what will be the time complexity if array not sorted? If array not sorted, right? One worst idea is going to be just to sort the array, which will take maybe merge sort. Using merge sort you can do because it is always n log n. Right? Apply merge sort, which will take n log n time. Afterwards, return a of k. If for this problem, if array sorted, answer is going to be constant. If array not sorted, one answer is going to be sort array and return a of k. So now you see different approach to find the kth smallest element in the given array using divide and conquer. How I will explain, right? So and one more thing, right? This algorithm is completely based on, right, quicksort algorithm, partition algorithm. This selection procedure algorithm, what I am going to explain now, it is completely based on quicksort partition algorithm. Right? Please be careful. And one more, some people are asking, if you solve this problem using divide and conquer, next, right, what is the first step? When the problem small. Nothing there. Right? If array contain only one element, then problem is small. Otherwise, problem is big. Some people are asking, if array contain only one element, what will be the answer? If array contain only one element, return that element. That itself is the answer. If array contain only one element, you can find out one smallest element only. That is the reason. Array contain only one, please return it. Otherwise, big problem, some story will happen. If you know partition algorithm, you know this particular application also. That is the reason after quicksort is over, immediately I am starting this. Some people are asking, sir, can you explain this story now? I am explaining. One numerical example I am taking, I am explaining. It is very easy also. You can easily follow. Right? Let's check once. Right? Let me take the one numerical example. See the example? Array A. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So this is the array which contain 9 elements. Next one. Let me give some values. 80, 20, 70, 50, 60, 15, 19, 13, 56. Some numbers I have to write, I written. Right? Indexes also, everything ready. And one more. What is the one more input required to this problem? Right? You want to find out kth smallest element. Some k also required. I am writing some k. K is equal to. Within few minutes I will fill that also. Right? So I have to find out kth smallest element. If k value 5, fifth smallest element. If k value 3, third smallest element. If k value 9, ninth smallest element. Something like that will come. To explain this problem, I took one array. To explain this problem, with the help of numerical example I want to explain, I took one array. See this. I took one array. This array contains 9 elements. In this array, I want to find out kth smallest element. Right? What is the k? I will fill within few minutes. Let me ask one small line now. Before going to the answer, let me ask you one small line now. In this array, who is the first smallest element? In this array, first smallest element 13. Second smallest element 15. Third smallest element 19. Right? I think fourth smallest element 20. Next, fourth smallest element also over. Next one, fifth smallest element 49. Right? Next one, like that, all smallest elements are there. In this array, first smallest you know, second smallest you know, third one, and so on. Many are there. Now can you help me? In this array, I want to find out fifth smallest element. That is my goal. right? There is one array. In this array I want to find out fifth smallest element. How to find out? Using this procedure, using selection procedure. It is not selection sort, it is selection procedure. Using selection procedure, how to find out in this array, right, fifth smallest element. I am explaining now. I am explaining. Carefully listen. I am starting. Small problem, it's okay. Only one element, it is a small problem. Return that element, that is fine, right? Big problem. Let's talk about big problem only, right? Now I am starting. See this one, I am starting now. How to find out? How to find out fifth smallest element in this given array, right? I am starting. As I mentioned to you, this algorithm completely based on partition algorithm. Let's see this one. I am applying partition algorithm. I am applying partition algorithm. Please be careful. Partition algorithm on n elements. How much time? Partition algorithm on n elements, time complex order of n, you know, one for loop required. Yes. On this array, partition algorithm I am applying. See this one, I didn't mention what is the pivot and all. By default pivot first element, right? So on this array partition algorithm I am applying, time complex order of n, it's okay. Now can you after partition algorithm what will happen? Pivot element will go to correct place. Let me write the idea of the partition. You know partition algorithm very well. In examination partition algorithm, whatever algorithm you know, just apply that. Now I am applying roughly partition algorithm behavior, you know, roughly I am writing. Major point I am writing. In this particular array, if you apply partition algorithm by taking 49 as the pivot, 49 will go to correct place. Less than pivot is one side, more than pivot is another side. Can you help, you know? Scan the array one time. Who are the less than pivot? Just scan one time. These order may change because I am explaining roughly partition algorithm. Major point. In exam, if they ask to apply partition, whatever algorithm you know, just apply it. If I apply same algorithm again and again, it may be time consuming and all. That is the reason I am writing the idea of the partition algorithm. Major point I am writing. Pivot will go to correct place. Yes. Less than pivot one side, more than pivot other side. Can you help me know the less than pivot? Scan once, 20. Next. Less than pivot, 15, 19, 13. Can you help me know who is the more than pivot? Who is the more than pivot? Scan the array and check who is the more than pivot. Start from the starting. I think 70, 50, 60, 56. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So on this array apply partition algorithm which will take n time, right? Fine. So if you take the pivot element as 49, pivot will go to correct place, less than pivot one side, more than pivot other side. Fine, it's okay. Roughly I written. Major point I written clearly. 49 will go to correct place. That is the major goal of the partition algorithm. That is the major goal. Please be careful. On this array, if I apply partition algorithm, less than 49 one side, more than 49 other side, that's fine. Right? So, see this one. This is the current status. I am thinking that you are absolutely fine now. Please help me. On this array, if you apply partition algorithm by taking the 49 as a pivot, pivot will go to correct place, it's okay. Finally, it will return one number also. Right? What is the number? Assume that it is written some number m. M is 5. Pivot element position, you will return. Partition algorithm is over by after keeping the pivot element in its correct place. It will return the position also. What is the position of the pivot element? 5. So m is 5. Can you help me one small, partition algorithm is over. It returning 5. What is the meaning? Partition algorithm is over. It return 5. What is the meaning? Right? It want to say that pivot element went to the correct place. Its correct place is 5. Indication that pivot element is there in its correct place 5. Indication that pivot element is the fifth smallest element. Who is there in the fifth place? Pivot element. And not only that, pivot element is not only in the fifth place. Pivot element is there in its correct place. What is the meaning of it is correct place? What is the meaning? After sorting also is position same. Pivot element went to the correct place means after sorting also his position is same. You only say after sorting who will be there in the fifth place, fifth smallest element. Pivot element is saying that, right, I went to my correct place. My correct place is 5. What is the meaning? After sorting also his position is same. That is a 5 only. That means pivot element is the fifth smallest element. Please be careful. Partition algorithm is over. It returned 5. What is the meaning? You know fifth smallest element. It is saying that, right, the element which is there in the fifth place is 49. Right? It is the correct place and all. It is saying like this one. Now see the interesting answer. Partition algorithm is over. M is 5. Indication that this is saying that I know fifth smallest element who is. But can you help, you know fifth smallest element, it's okay. But what you want? Kth smallest element. After partition algorithm is over, m value 5 means you know fifth smallest element. But I want kth smallest element means E also want fifth smallest element, that is also fifth smallest element. I think nothing. After partition algorithm is over, just compare is m is equal to k or not. What is the reason? It is saying that I know mth smallest element, but what algorithm saying? I want kth smallest element. Please check is m is equal to k or not. Yes, true. True. Then what is the answer? Return a of m. M is 5. A of m means 49. A of m is 49. If you want, you can return the position also. If you want, you can return the value also. That is up to you. Return position of the kth smallest element. 5 also you can return. It's up to you. If you want, you can return value also. Right? Fine. Now I am repeating once again. If anyone asks you if anyone asks you selection procedure, please explain. In selection procedure, one array is given, one integer k given. You have to find out kth smallest element. Right? So in the selection procedure, it is one of the divide and conquer application. What will you do is just apply partition algorithm. It return mth smallest element, but you want kth smallest element. Please check m is equal to k or not. True. Then return a of m or a of k. Right? Something like that. Fine. I'm thinking that you are absolutely fine. Suppose, right? I think, can you help? If you stop, if you are lucky, what happened? Is m is equal to k? Yes. Then stop. Can you help? If you stop now, what is the time complexity? Right? Order of n, because only partition algorithm I applied. If you are lucky, you can stop now. Time complexity order of n. Some people are asking, sir, you done the division. How time complexity order of n? I done the meaningful division. Meaningful division means comparing with all. One loop required. Partition means one loop required. Order of n time is over, m is equal to k, stop. Supposition that, right? So if you are lucky, this is the story. If you are unlucky, supposition that I want to find out, supposition that I want to find out eighth smallest element. I want to find out eighth smallest element. See what will happen. Just ask. Apply partition. Yes. He is saying that I want mth smallest element, but I want kth smallest element. Please check is m is equal to k. True, then stop. If not, ask this m. Right? I want 8th smallest element, but you are 5th smallest element. What should I do? He will say that if I am 5th smallest element, less than me means first smallest element, second and all, left side. More than me means 6th smallest element, 7th one and all, right side. Just go right side and check. Comparing the mth smallest element, kth smallest element is bigger. So m value 5, k is 8. Means you want more than 5th smallest element. Simply apply selection procedure in this area. See this one. Selection procedure in this array is equal to apply partition, check m is equal to k, true, stop, otherwise apply selection procedure on the right side. Applying selection procedure is nothing but inside there is again partition. Again partition algorithm on n elements. Right? Order of n time, that is okay. Now apply by taking first element as a pivot. Roughly same thing I am doing. 70 is the pivot element, less than 70 one side, more than 70 other side. Can you choose the less than 70, scan once? Don't bother anything about the order, scan once and write. Less than 70, who are those? Who are those less than 70? Right? So let me check this one. 50, 60, 56. Less than 70, these many. Who is the more than 70? No one. Let me give the positions 6, 7, 8, 9. Right? Not only that, it will return m. What is the m value? 9. After partition algorithm is over, one more n time, just ask, is m is equal to k? K is 8. Right? M is 9. If both are equal, stop. Otherwise, ask him. You are the 9th smallest element, but I want 8th smallest element. Which side I have to go? Go left. Right? Apply selection procedure on the left side. Partition algorithm on n elements. Right? Order of n time. Time complexity will see. You know partition algorithm n time. Fine. That's okay. Now apply partition algorithm on this. What is the answer? 50 will go to correct place. Less than 50 one side. More than 50 other side. Who are the less than 50? No one. Who are the more than 50? 60, 56. Positions if you observe. 6, 7, 8. Right? Can you help in what it will return? It will return m is equal to 6. Now check. Is k is equal to m? Both are equal. If k is equal to m, stop. Otherwise, what is the answer? Ask the m. You are the 6th smallest element, but I want 8th smallest element. What he will say? Go right. Again apply partition algorithm. Time complexity, don't bother. You know very well about partition algorithm, time complexity. Partition algorithm on n elements, n time. N elements, n time. If it is less element, less will come. Don't worry. See, so I am not writing anything wrong here. See, how many elements are there? That much time. Partition algorithm on n time, right? On n elements, n time will come. Right? It's okay.
Just see numerical example only. Don't worry anything about time complexity. After writing algorithm, everything clear to you. Partition algorithm on n elements, n time. Now can you help in what is the answer? 60 will go to correct place, less than 60 one side, more than 60 other side. Who is the less than 60? 56. Who is the more than 60? No one. Positions 7 and 8. What it will do? Right? M is equal to how much? 8. M is equal to 8. Now let's see this one. After partition algorithm is over, he is saying that I know mth smallest element, but I want kth smallest element. Ask, is m is equal to k? Yes. Then stop it. Then return m or return a of m. If you want value, a of m. If you want position, write m like that. Then you can continue. So suppose that some students are asking, now also not matching. What is the answer? I think you will go either left or right. Assume that you went left, one element, then that is the answer. Continue. If you are lucky, what will happen? Starting itself you can stop. See, if you are lucky, here itself you can stop. Then order of n time. If you are unlucky, few more n's required. Worst case what happened? Continue until one element will come. Suppose assume that now also fail. I may go left, I may go right. Because of right, no one, I will go left. Left only one person, that will be the answer. Only one person, no need to ask also, return that element. So this is the answer. So selection procedure is nothing but right, partition algorithm only. Inside selection procedure you will apply partition algorithm. After partition algorithm is over, if you are lucky, matching there, stop. If not, what is the answer? You applied, see this one, inside selection procedure, partition algorithm. After partition algorithm is over, m is equal to k, stop. If not, what will happen? If not, you may go left, you may go right. Can you help me now? Partition algorithm dividing the given array two parts, it's okay. But are you going both the side or one side? One side only. Either left or right. It is something like binary search. But one thing, in the binary search you will do blind division, 50-50. But here meaningful division. So this problem is combination of binary search and quicksort. In quicksort both the sides you will go. In binary search only one side you will go. But in the quicksort meaningful division. In the binary search blind division. In division point of view quicksort, meaningful division, right? But in terms of the both the side, right, binary search, why? Only one side you will go. It is a mixed combination of binary search and quicksort. Please be comfortable with numerical. If you want, you can check every time. One side I am going. See this one. I went to which side? Left side. I went to which side? Right side. I went to which side? Here itself you can stop. In the first time where you went, right? I think matching there, no. Right hand side you have to go. Here left side. Every time only one side. Quicksort go both the side. Here only one side. Right? So it is internal algorithm if you observe. Other than the division if you observe, it is exactly like binary search. Division is exactly like quicksort. Combination of those two algorithms. Time complexity, if you are okay with the numerical example, we will go to the time complexity and all the things. Let me write the algorithm. If you are okay with the numerical example, let me write the algorithm. I am writing the algorithm. It is very simple. Please listen. Numerical example you are okay means this algorithm is going to be very simple. I am starting. See the algorithm. What is the name of the algorithm? Selection procedure. Or selection I am writing. Selection procedure, I written the selection. Selection algorithm, input, array A, which contain, what is the answer? P to Q elements. In that I want to find out kth smallest element. Array A, which contain P to Q elements. In that I want to find out kth smallest element. Can you help me now? What is the first step? First step, I think as usual. Don't worry anything about the if part, right? So let me write now. If P is equal to Q, what is the meaning? Only one element. If only one element. If you want position, return P. Otherwise return. What is the answer? Otherwise return A of P or A of Q. Isn't that I want element? Then like this. If P is equal to Q, then return A of P. Right? So I want the kth smallest element. I got to know, right? P is equal to Q means only one element is there. That itself is the answer. But one thing. If you want kth smallest element, assume that k value 5. If you want kth smallest element where k value 5, then number of elements cannot be less than k. Please be careful. You want to find out kth smallest element where k value 5. Then number of elements are only 3. Then how can I find out kth smallest element? Right? Here the assumption is going to be where k is less than or equal to n. Please be careful. N elements are there. You want to find out kth smallest element where k is less than or equal to n. That is the condition. If you want, I will write in algorithm also that line. If you want, I will change it. See, an array of n elements and integer k. right? Within the brackets I am writing k less than or equal to n. If the array contain 10 elements, how can you find out 15th smallest element? There is no meaning in that. So assume this is the case. If array contain n elements, that I want to find out kth smallest element where k is less than or equal to n, and one more. If you want position, return position. If you want value, return kth smallest element. Return kth smallest element. That is also okay. Return kth smallest element. Fine. Anything is okay. Based on that, we can write the algorithm. Now I am writing the algorithm. See, array A which contain p2q elements. In that kth smallest element, I want to find out. Try to remember k is less than or equal to n. That is fine. If p is equal to q, return a of p. That is fine. Now see the answer. Else. Now see the answer. Else what should I do? Else. Can you help me if you come to the else part? Small problem or big problem? Big problem. What should I do? Apply partition. Apply partition algorithm on array A which contain p2q elements. Right? After partition algorithm is over, right? You got m. What is the meaning? Partition algorithm is saying that I kept the pivot element in the mth place. Means right? Pivot element went to the correct position of the right is place. Correct position means what? After sorting, right? Who will be there? After sorting, who is there in the fifth place? Fifth smallest element. Apply partition algorithm on array A which contain p2q elements. It returns m. Means it returns m. What is the meaning? Pivot element went to the mth place. And not only that, pivot element is saying that I went to my correct place is m. What is the meaning of I went to the correct place, my correct place is m? What is the meaning? After sorting also his place is same, m only. Indication that after sorting in the mth place, mth smallest element is there. That is the indication. So indirectly this line is saying that I know mth smallest element. Indirectly that is the meaning. Because he kept the pivot element in the mth position, which is the correct place of the pivot element, means he know mth smallest element. He is saying like this one. But I want kth smallest element. He is saying that I know mth smallest element. Then check. If you are lucky, it will happen. Then check is m is equal to k. I want kth smallest element. You are saying that you know mth smallest element. Please verify both are equal. If true, what is the answer? Return a of m or a of k. Because of you want kth smallest element in terms of k, I am writing. Suppose this is true, this is the case. Suppose it is fail. This is true, you will go this side. Please be careful. If it is true, you will return. What is the meaning? You will go out of this function. If it is true, you will return out of this function. If fail, then only will come here. No need to write else also. That is the effect of the return keyword. Condition true, return means you will go out of this function. Return means what? Pop. This function is popped. So if it is true, you will go out of this function. If it is fail, then only will come. That is the reason no need to write else also. Now you came here means it is fail. Then what should I do? Then you have to write like this one. What is the answer? If k less than m. What is the meaning? You want the kth smallest element, right? He is saying that I know mth smallest element. Then unfortunately both are not equal. I asked the m. I want kth smallest element. You are the mth smallest element, right? So you are not equal. What should I do? He simply said that you are less than me. What is the meaning? You want less than me smallest element. Means left hand side is there. You please go and verify. Now left hand side you have to apply selection procedure. What is the answer? Apply selection procedure. Apply selection procedure. Using recursion, apply selection procedure. Array A which contain, what is the answer? P2 m minus 1. In that find out kth smallest element. K less than m, please be careful. So left hand side you are coming. How many elements are there? P2 m minus 1. Definitely this range is, if you observe, right, this range is going to be less than or equal to k, right? Sorry, this range is going to be, right, this range and this k if you compare, k less than or equal to this range. Don't worry. Apply selection procedure on the left. Otherwise, apply selection procedure on the right. See this one, else is there. What is the meaning? Either first function call or second function call. A, what is the answer? M plus 1 to A, m plus 1 to Q. In that find out kth smallest element. If k less than m, then go left side, otherwise go right. It is something like, see this one, if you observe clearly, from here to here binary search, here to here binary search. This is only for quick sort, here to here binary, and one more. If you remove this else part, if you remove this also, these two conditions and this else part if you remove, it is called quick sort. Suppose if you kept everything as it is, here if you replace this one by I plus j by 2, this will become binary search. Right? Anyhow, that is okay. You know very well. So this is the algorithm for the selection procedure. Just check small problem, then return it. Otherwise apply partition. Ask m is equal to k, then return this. Otherwise go left side or go right side. Right? And because of it the meaningful division, how much time? N time. You know very well. Otherwise you may go left, you may go right. Yeah, else if you remove both the side you will go, that is becomes quick sort. If you replace this one by p plus q by 2, it will become binary search. Because of blind division. Blind division means left half, right half. It is the meaningful division. Left small people, right greater people. Now some students are asking, sir, in the binary search also, if I do blind division also, left small there, right greater there, then why not here? Why not here? Try to in the binary search array already sorted. Because of array already sorted, left smaller, right greater. But this array is an unsorted array. I don't know who is left, I don't know who is right. So partition algorithm you have to apply. Apply partition, so you will keep in the correct way. Less than pivot one side, more than pivot other side you will keep. Because in the binary search algorithm you will do blind division, still left smaller, right greater. Why? What is the reason? Array is sorted. But here array is unsorted. If you do blind division, no one knows what is left, what is right. So because of array unsorted, do meaningful division, left smaller, right greater will come, accordingly you can behave. Right? Fine. I am thinking you are absolutely fine. It is a selection procedure. To find out kth smallest element, please be careful. It is a nice algorithm using divide and conquer technique. Right. Now what is the next one now? Time complexity finding. Let me do that also. Time complexity finding. Let me write. See this one. See everyone now. Recurrence relation for a time. I want to find out recurrence relation for a time. Right. Let me write this also. Tn is equal to time complexity of time of selection of n. Recurrence relation for a time. Right, Tn is equal to time complexity of selection of n. Fine. Then if you are okay, see the recurrence relation. Tn is equal to, can you say small problem, constant time. If n is equal to 1. In terms of p and q also you can write. P is equal to q means one element. What is the meaning of n? Q minus p plus 1. You know very well. Even though p and q there, just I am using n. I want to say that number of elements here, q minus p plus 1. Right? If you want, I will write. Right? So let me write. It will goes to q minus p plus 1. These many elements are there. Time complexity of this algorithm on n elements, t of n, where n is q minus p plus 1, right, is equal to constant if one element is there. Can you help me now? Big problem, then what is the answer? Partition. How much time? Order of n. Which case? Every case. So n plus. Partition algorithm n plus. Next one. Can you help me? After partition algorithm is over, please listen. After partition algorithm is over, is m is equal to k return? Now see the interesting answer. After partition algorithm is over, if m is equal to k, stop. Return means what? Stop. If you are lucky, here itself you can stop. If you are lucky, here itself you can stop. Can you help me now? If you stop here itself, how much time? N. If you stop here itself, how much time? N. Please be careful. I am going further. What is the meaning? I am going further means, right, worst case or average case. Please be careful. Worst case or, if you stop here, best case. If you go further, worst case or average case. Please be careful. I am going further. It will be worst case or average case. Right? Anyhow, I will explain. I will write all the small things which are pending further. Let me write the reconciliation. Right? So this one, if I stop here itself, best case. If I stop here itself, best case. If I am going further, worst case and average case. Partition n time, m is equal to k, some constant, return a of k. So I think it's the best case. Stopping, if you stop here, best case. So if anyone asks you selection procedure will be best case when? What is the answer? In else part, partition is over, m is equal to k, stop. Then best case order of n. It is a special case, afterwards I will write. Please be careful. I am going further means worst case or average case will come. Right? Fine. Anyhow. So let's see this one. Time complexity of this particular algorithm is going to be order of n. Fine. So because of this is true, you will stop here. If not, then go further. Can you help me now? Can you help me now? See this one. See the interesting one. This entire story, small work is there. Partition algorithm, m is equal to k. If not, k less than m. This entire story, n time, because small constants they are there. After partition algorithm is over, m is equal to k, k less than m, small work. Overall will take constant time. Sorry, overall will take n time. This small constant and this n. Overall is going to be n plus constant, overall is n. Right. After n time is over, if you are lucky, after n time is over, stop. Best case.
If you are unlucky, after n time is over, you have to go either left or you have to go either right. Can you help me one small line? If you go left, some time will take. If you go right, some other time will take. Can you help me now? How some other time? If you go left side, what is the answer? But one thing is true. Partition algorithm is a meaningful division. It is not a blind division. You cannot say 50-50 here. Left half, right half, you cannot say that. Because it is a meaningful division. Anything can happen. Can you help me now? If you are lucky, what happened? It is the Tn by 2, it is the Tn by 2. One more case. If you are lucky, what will happen? It is the Tn by 5, it is the T4n by 5. See, this one, fraction of n elements one side, remaining other side, then also best case, average case. If you are lucky, 50-50, or fraction of n elements one side, remaining is other side, like that. Can you help me? If you are unlucky, what happened? If you are unlucky, worst partition, what is the answer? Left no element, all are right. Or left all elements, no one is on the right. And one more, when the worst case will come, constant elements one side, remaining other side. Anything can happen. So, best or many cases are there, right? After partition algorithm is over, if you are lucky, best partition. If you are unlucky, worst partition. But let me write the actual one. Actual one, how many elements? P to m minus 1. How many elements are there? You know that formula. What is that? M minus 1 minus P plus 1. Both are cancelled, so m minus P will be there. Can you say right hand side, how many elements are there? So, what is the answer? Q minus m minus 1 plus 1. Both are cancelled, Q minus m. So, like that. Let's see this. I am writing. This will goes to T of m minus P. Please check. This is T of Q minus m. Right? Like this. But only one side, else part. I am writing now. I am writing. Please see. Selection procedure time complexity Tn is equal to n for partition. After partition is over, you may go left, you may go right. Let me write now T of m minus P. See this one, T of m minus P plus T of m minus P. Will you go both the side or one side? Right? One side only. Either left side or right side. You cannot write plus. Either left or right. Don't include both. T m minus P or T q minus m. If n is greater than 1, this is the story. So, small problem, this much time. Big problem, partition is over, you will go either left or you will go right. It is the best partition, worst partition, afterwards we will see. This is the way. This is the way. I am thinking that you are absolutely fine now. Listen everyone. Listen. So, this is the reconciliation for time complexity of, right? Time complexity of selection procedure. Everything fine? See this one. You may go left, you may go right. After n, you may go left, you may go right. Suppose, that is the interesting answer. Assume that you are lucky. What will happen? If you are lucky, time complexity of the selection procedure Tn is equal to partition is n time. Partition is n time. Next one, best partition happened. Means 50-50. So, one side only will go Tn by 2. So, this is the best case. This is best case. Please be careful. So, listen everyone now. Time complexity of the selection procedure Tn is equal to n plus you may go left, you may go right. Best case, what is the meaning? If best partition happened, right? Tn is equal to n plus Tn by 2. Either left side or right side. Otherwise, Tn by 5, T4n by 5. Otherwise, Tn by 10, T9n by 10. Exactly like quicksort. In quicksort, both the side you will go one side here. In quicksort, best partition or worst partition, you will go both the side. Here only one side. This is the best case. This is the best case. Can you help me now? Everyone at the best case and average case also, because most of the time this only will happen. Average case also. Right? So, Tn is equal to n plus Tn by 2. If you solve this one, I have done many times. N plus n by 2 plus master theorem also you can apply. N by 2 square plus and so on. N by 2 power log n. Because divide by 2 by 2 by 2 by 2 log n time. Right? So, if you see n common, right, it will goes to 1 by 2 whole power. First one, 1 by 2 whole power 0, 1 by 2 whole power 1 and so on. Lastly, 1 by 2 whole power log n, roughly. Which will goes to what is the answer? N into decreasing GP series order of 1. Final answer is going to be big O of n. So, selection procedure, best case and average case. When the best case will come, best partition, average case also same story, and right, that is fine. Can you help me? If you do how many time? Log n time. Log n stack space, that's okay. Now go to the next one now. Right? So, if you are unlucky, assume that worst partition will happen. Worst case, what is the answer? Worst case, Tn is equal to selection procedure time. Tn is equal to n for partition. Because of your unlucky worst partition, T of 0, T of n minus 1. Right? Let's simplify this one. N plus T of n minus 1. n plus t of n minus 1, right? So if we solve this one, if we substitute like n time, right? What is the answer? 1 plus 2 plus and so on, n will come, sum of n natural number, big O of n square. See this one, see everyone now, selection procedure, worst case is like quicksort only, quicksort also n square, quicksort recurrence relation also same. Worst case recurrence relation for quicksort, all will go one side, right? Actually constant elements one side, remaining elements other side. But here in the case of selection procedure, one side only will go, not constant and all. I'm removing this. One side only. All elements went to one side, but here one side only will go. In the quicksort, left and right both will go. Constant also you will go, which will take constant time, it's okay. N time for partition, right? Afterwards, right? Because of worst partition, all went to one side. That side only you are going. All went to one side, that side only you are going. Finally, this is. Right? Fine. I am thinking that you are little bit okay. Please see this. Selection procedure. Carefully listen. Selection procedure. Numerical example, you are comfortable. See this. Selection procedure. Numerical example, you are comfortable. Based on that, I written the algorithm. By seeing algorithm, you got to know partition. Afterwards, if you are lucky, stop. Otherwise, you may go left, you may go right. So, I written partition n plus you may go left, you may go right. Best partition this, worst partition this. Now, can you help me one small line now? Right? Selection procedure best case n, average case also n. When best partition happened. Now, one more interesting thing I want to ask you. Selection procedure will give best case in 2 times. Selection procedure will give best case 2 times. When, right? So, when it is, right? After applying partition, if m is equal to k, stop. Then also n. One more. If m is equal to k fail, right? Then you call the partition algorithm m is equal to k fail. But best partition happened. Then also n will come. See this one. Best partition happened. Then also n. And one more. Partition algorithm is over. M is equal to k. Then also n. If you stop here, then n. If you don't stop here, best partition happened, then also n. So, two times best case will happen for a selection procedure, right? M is equal to k itself, you can stop. Otherwise, you may go left and right, but best partition happened, right? Which is nothing but average case. Time complexity of selection procedure is order of n, best case and average case. Worst case is going to be order of n square. After partition algorithm is over n time, right? Worst partition happen means all elements are going one side. Yes, this is. You may say that, sir, constant elements another side. Even though constant elements are another side, this algorithm don't go both the side. One side going, that is also more element sides. Then worst case will come. See this one. When the worst case will come for selection procedure, after applying partition algorithm, worst partition happened. Means one side constant elements, other side remaining element. That side you went. Even though you can go one side, more element side you went, constant element side you didn't went. In the quicksort, both the side you will go, constant and remaining. But here, no chance of constant. Worst case means what? Worst partition means more element side, that side only you are going. If you solve this one, order of n square. So, selection procedure and quicksort both will be same. Quicksort, both the side you will call the function call, but here only one side. Can you say quicksort best case? Because of both the side you are doing n, right? N plus Tn by 2, n log n will come. Because of two function calls in the quicksort, right? 2Tn by 2 plus n, which will go to n log n. But here you are going only one side, Tn by 2, right? This is going to be order of n. Quicksort best case is n log n, but here is n. Average case also n. Quicksort worst case and this worst case similar, n square. Right? N square. Right? Please be careful. Let's see the extra stack space. So, can you help me now? To this program, right? Non-recursive program is possible. It is like binary search. See this one. It is like binary search. Extra space. See this one. Non-recursive program. Like binary search. So, what is the answer? Order of 1. Every case possible. I am saying all the shortcuts is one. Right? Extra to this problem. Selection procedure. Right? Selection procedure. Let me write. Selection procedure, whatever is there, right? Not to this algorithm, non-recursive program I written also. Extra stack space, non-recursive program, like binary search you can write. Non-recursive program like binary search. Order of 1 space every case, right? To this program like this. right? Best case and average case log n, worst case is n, that is okay, right? So listen everyone, listen, this program is given, they are asking, then follow that, right? Normally if they ask you selection procedure, stack extra space how much, right? Like this, right? Fine. And one more small thing I want to say to you, please listen. One more small thing, really not required, I am saying that one. I remember this, just let me say this one. Extra stack space, not for this program, right? Non-recursive program, order of 1 every case. If they don't give this program, if they ask you extra stack space how much, say this, right? Next one, to this program, let me write now, to this program, extra stack space. Extra space or extra stack space, whatever it is, right? Extra space to this program, I am writing, see, to this program extra space. See the answer, best case, worst case and average case, right? Now can you help me now, worst, what is the worst case stack space? To this program means this one, can you help me now, right? Extra space to this program, how much? Can you say worst case n, can you help me now, what is the average case? Average case, best case is what the answer? Log n. That is also okay. But one thing is true. This algorithm having two best cases. One best case is best division. One more best case is. After partition algorithm is over, m is equal to k, stop. After partition algorithm is over, m is equal to k, stop. What do you mean? No need to call further. I think order of 1 stack space. This program time complexity, everything okay. Let's come to the next one. This program, stack space how much? This program stack space, right? This program, see I written line also. This program stack space is going to be, right? Which is nothing but extra space. Extra space is going to be best case, worst case, average case. See all three I written. This program, extra space or extra stack space, whatever it is. Three things are there. Can you help me now? This program means, listen, this program means this only. What is the worst case stack space? N. So worst case n. Can you help me now? This program in this one only. What is the average case stack space? Log n, right? Average case is log n. And one more thing. This program having best case two scenarios. One, best partition happened. That is also best case will come. One more best case. If you stop here itself, you call the function, you came inside, if you stop here itself, m is equal to k, stop. If here itself, if you stop, no need to call recursion further, right? What is the answer? Time complexity n, stack space is 1 because you are not calling further. So two best cases are there, right? One best case will give order of 1. What is the meaning of best case? Minimum amount of space required, it is the minimum. Two best cases are there, this best case will take 1. Right? This is the time complexity point of view, best case and average case here, same here. Best case and average case log n. But here, average is log n, right? Best case one more also there, constant. Best case means what? Minimum space required. Yes. To this program, whichever program we written, to this program, best stack space is order of 1, right? Worst case space is going to be n, average is log n. Yeah. See the time also. You know very well time. Time is both the cases same. Recursion, non-recursion don't decide the time. Who will decide? Logic will decide. Time complexity. What is the answer? Best case and average case. How much? N. You know already there. Worst case n square. Right? So this is the selection procedure and all. Right? Let's see one more point I want to say to you. Please be careful. Right? This is the very, very important point. See this one. Note. Note, please be careful, see this one. Worst case time complexity to find kth smallest element worst case time complexity to find kth smallest element in an unsorted array is order of n, right? Using, I am writing here also, hint also I am writing, using median of Mediana 5 algorithm. It is almost like selection procedure, only little bit different. I want to explain both, but really not required. This statement required, take care. It is a very, very important one. Worst case time complexity to find kth smallest element in an unsorted array is order of n using Mediana 5 algorithm. Using Mediana 5 algorithm. From today onwards, if they ask you selection procedure, then go there. Whatever we explained, selection procedure, right? So if someone asks you, right? They didn't mention the name. Someone asks you to find out kth smallest element, what is the time complexity? Worst case, what will you say? Because of they didn't mention the selection procedure and all, just this algorithm. From today onwards, kth smallest element to find out in an unsorted array, time complexity order of n, every case. Worst case itself n means, best case definitely less than n not possible, because you have to do at least one scan, right? Without comparing, you cannot say who is the minimum, who is the maximum. So at least one scan required. But interesting thing is worst case also n. Worst case n means every case n, right? That algorithm name is Mediana 5 algorithm. If they didn't mention any algorithm, if they ask you kth smallest element to find out worst case time how much, simply say n. This is required. It is there in the Coreman book also, you can go through it. Mediana 5 algorithm. Right, let's see the next application. Next application is Strasson's matrix multiplication. Strasson's matrix multiplication, right? So what is the purpose of this one? I will explain. At the end you will get this topic, right? In this entire one, lastly this topic will come. For that many basics required. All the things I will explain. Please try to get as much as possible. This is the next application of the divide and conquer, right? Let me say clearly. See this one. All the things which are required, I will say one by one, right? Listen properly. Listen. See everyone now. I'm talking before going to this entire actual story. Let's see some small things. See this one. Matrix addition. Just I have to talk about matrix addition. I'm doing. See everyone. Array A which contain n elements. Array B, array or matrix, right? Matrix A which contain, right? So what is the size? Let me write. See this one. This may be something like, if you want I will write 3 by 3 also okay, 4 by 4 also okay, everything fine. Let me write 3 by 3. Next one, array B or matrix B which is of size 3 by 3. So because of matrices, everyone know array, matrix both will be same, right? 2D array, right? 2-dimensional matrix, both will be same. In mathematics terminology, matrices, right? In computer science terminology, arrays and all, right? It's okay, fine. See this one. Our goal is going to be now matrix addition, right? Final goal is matrix multiplication. Now let me do matrix addition. I took two matrices A and B. A size is going to be 3 by 3. B size also 3 by 3. Let me write roughly. Right? Let me write roughly. A, B, C, D, E, F, G, H, I. Next one. B, C, D. Something I have to take, I am taking. E, F, G, H, I, J. I took two matrices A and B. I am repeating once again. See this one. Next application of divide and conquer is going to be Strasson's matrix multiplication. Right? For that, right? The things which are necessary I am explaining. See this one. Right? Our topic is this. Matrix, right? Strasson's matrix multiplication means matrix multiplication is our goal. Right? Before going to that, few things required. That is the reason I am explaining this one. Matrix addition. First matrix. For this topic, first thing is going to be matrix addition required. Yes, I written. See this one. I took two matrices A and B. A size is going to be 3 by 3. B size is going to be 3 by 3. Both are 3 by 3. Now can you help me now? C is equal to A plus B I want to do. C is equal to A plus B, which is of size again, you know, 3 by 3 only you will get. 3 by 3 you will get. Can you help me one small line? How to get first element of C? How to get the first element of C? Let me write now. Right? 1, 2, 3. It is also 1, 2, 3. Can you say how to get the first one? First one how to get? Everyone now. Just A plus B add, you will get this. Next one. I think this one. If you want first row, first column element. If you want first row, first column element in both, you add. Next one. First row, second column element. If you want first row, second column of both, you add. Like that you will get. Everywhere one addition required. Everywhere one addition.
right? Everywhere one addition, like 3 by 3, right? Like that. Right? If you want, I will make proper. Right, like this. C is equal to A plus B, right? I think for every person, see this one. Third row, see this one. Let us assume that, see this one. 1, 2, 3. See this one. Third row, second column if you want. Same thing here. Third row, second column, both the things you add. Next one. Second row, third column if you want, same. Second row, third column, you add, you will get. Right? You will get. Next one. I am thinking that you are really comfortable. Now can you say the time complexity now? Can you say time complexity? See this one. C matrix contain how many elements? C matrix contain how many elements? What is the answer? 3 by 3 means 3 square elements. N by n means n square. N square elements required. C matrix contain n square element. C matrix contain n square element. C matrix contain n square. Now see this one. If C matrix contain n square element, that is fine. See this one. N square into every element required. How many additions? See this one. If you want first element, both the first elements you add one addition required. See, isn't that this is a plus operator? Right? If you want, I will do that also. I am deleting now. Right? I am deleting now. Now see this one. If you add both the first elements, if you add both the first element, you will get first element. If you add both the second element, you will get the second element. Like that. So one addition for every element, one addition required. Can you help me now? C matrix contain how many elements? N square elements. Every element required how many addition? One addition. You know addition will take constant time complexity. What is the reason? Loops only will take time complexity. To do one operation, constant is enough. So finally time complexity order of n square. Right? So time complexity is one. Adding two matrices of size n by n will take time complexity order of n square. Every case, best case, worst case, average case. It is very easily I explain to you. Let me repeat those people who disturb a little bit also. See this one. Our goal is going to be Strassen's matrix multiplication. Means our actual goal is matrix multiplication. Right? But if I want to explain total story, right, matrix addition required first. So I written a matrix addition. Two matrices I took A and B, A of size 3 by 3, B also of size 3 by 3. Now C is equal to A plus B is my goal. If at all A and B are 3 by 3, C also contain 3 by 3. So can you help me now? To get the first element, how to get? Both the first elements you add, one addition you do, between them you will get. How to get the second element? Both the second elements you add, you will get the second element. Like that continue. See this one. Finally, C matrix contain 3 by 3 means 3 square elements, n by n means n square elements. So n square element, n square into every element to get one addition is enough. One addition will take constant time. So finally order of n square, right, time complexity to add two matrices of size n by n. Every case adding two matrices of size n by n will take time complexity order of n square. Right? Simply two loops required. Everyone know. Program also you can write simply two loops. Only for namesake I am writing, really not required. See this one. For I is equal to 1 to n. For j is equal to 1 to n. Cij is equal to, what is the answer? Aij, Bij. That's it. Nothing, no logic. Simply adding corresponding element. For I is equal to 1 to n, for j is equal to 1 to n, Cij is equal to Aij plus Bij. Simply two loops. Two loops will take time complexity n square. Every case, see this one, there is no chance of stopping in between. So every case, adding two matrices of size n by n will take n square. Fine. So matrix addition, I am thinking you are comfortable. Matrix addition, adding two matrices of size n by n, right? This is n by, it is a 3 by 3 means this is the story. If it is n by n, this is also n by n. Then it will also becomes n by n. N by n means n square element. Every element is one addition required. It is addition time. Some people are asking, sir, how can you say addition time is constant? Time complexity taken by loops only, not addition, not subtraction. All arithmetic operations will take constant time, right? Addition time, constant. Like that n square time, n square into constant, n square. Okay, fine. Matrix addition, everyone is comfortable. Let's go to the matrix multiplication. Matrix multiplication.
matrix multiplication. Let me do this also. Please be careful. Actually, this is the thing which is required. Adding two matrices of size n by n square, you know, only for namesake I explained. Even though you know, only for namesake I explained. This also you listen. This also you know. This also you listen. One time listen. One time listen. See everyone. A matrix. Next one B. Next one, I think everyone know one small story. What is that? See this one? Everyone know one small story. Let me explain that. Let me explain. Make sure that everyone listen. See this one. It is a 3 by 2. So A matrix is 3 by 2. Can you help? If you want to two matrices A and B, A is 3 by 2. It is a 2 means it should be 2 by something. Assume that it is a 2 by 4. If you want to, see this one, if you want to multiply two matrices, everyone know what is the answer? First matrix number of columns, second matrix number of rows, both should be same. Otherwise, you cannot multiply two matrices. Right? So, I want to multiply A and B. So, the condition, primary condition, in the first matrix number of columns is equal to second matrix number of rows. Right? It should be done like this. Now, some people are asking, sir, can you give one small example? Let's see this one. Only for namesake, let's see. See everyone now. It is a 3 by 2. 3 by 2. Let's see this one. 3 by 2. Right? Let me write here. 10, 20, 30, 40, 50, 60. 3 by 2. This one. 2 by 4. Let me write now. Let me write. 5, 6, 7, 8, 9, 10, 11, 12. Like that. Next one. If you are okay, now see the next story. See everyone. C is equal to A into B. So, can you help? A is 3 by 2, B is 2 by 4, right? What is the C is equal to A into B? What will be the C size? What is the answer? Everyone know what is the answer? These two will be cancelled. So, I think C matrix size is going to be 3 by 4. C matrix size is going to be 3 by 4. So, if anyone asks you, how 3 by 4, right? If you want, you can see now. You will get now. See this one. C 3 by 4. See this one. 1, 2, 3. 1, 2, 3, 4. 3 by 4. You know, everyone know this one. Only for namesake I am explaining. Here nothing new will come also. Right? C is equal to A into B means C size becomes 3 by 4. Right? I think it's a 1, 2, 3. It's a 1, 2, 3, 4. I think everything is ready. Now can you help? How to get first element? You only say. Right? You only say. C matrix, first row, first column. See this one. C matrix, first row, first column. If you want, I will let C 1, 1. C matrix first row first column, how will you get? Right? Answer is everyone now. C matrix first row first column, that is C11 if you want to get, then what will you do? First row first column, see this one. First row first column, right? Multiply. First row first column multiply. How it is? First element, second element, second element. Like that multiply. First row first column element if I want. First row first column you have to multiply. Then you will get this. Okay, some people are asking, sir, how to multiply? What is the answer? First one multiply 10 into 5. Right? What is the answer? 10 into 5. If you multiply 10 into 5 first, plus second one multiply. What is the answer? 20 into 9. Right? If you do that, you will get C11. Now, those people who are thinking that, sir, I am okay, can you help? First row, second column, C12, how to get? First row, second column, same. What is the answer? First row, second column, multiply again. So again, can you help me? What is the answer? First row, second column. First row, second column. What is the answer? First element, right? Multiply. 10 into 6 plus 20 into 10, like that. Like that, I think for every element, what is the answer? Year 1 multiplication plus year 1 multiplication. Like that you will get. Here also, what is the answer? Right? First row, third column, same thing multiply. First row, fourth column. First row, fourth columm, same thing. It is keep on going. What is this one? Second row, first column. C21. C21. C22, C23, C24, just multiply. So, like that it is going on. It is, what is this one? C31, C32, C33, C34, like that. So, for every element like this. Now, can you help me? What is the answer? Same. What is the answer? One multiplication here, one addition. Like that, everywhere it is going on like this. Now, if you are really comfortable, listen, if you are really comfortable, let me ask you one small line. See this one. Let me ask you one small line. See this one. For this one, how many multiplication? For this one, 2 multiplication. For this one, 2 multiplication. For this one, 2 multiplication, and so on. Right? If you are okay, can you say what is the C matrix size? 3 by 4. Now, see what I am doing. See this one. C contain
C contain how many elements? 3 into 4 elements. C contain 3 into 4 element. Now see the answer. What is the next line? See this one. Next line. Right? This will goes to 3 into 4. Right? 3 into 4 elements. It's okay. Can you say from where 3 and 4 came? From here. See this one. 3, 4. 3, 4. Next one. Every element required how many? Multiplication. Every element required 2 multiplication. What is the meaning? Here 2 multiplication. Here 2 multiplication. Everywhere 2 multiplications required. Now see the answer. 3 into 4 into every element required. What is the answer? 2 multiplications. 2 multiplications. Combinedly, what is the answer? 3 into 4 into 2 multiplications. Can you say multiplication will take how much time? Constant time. Finally, time complexity, big O of 3 into 4 into 2. Right? This much time for a multiplication if the given matrices sizes are 3 by 2, 2 by 4. Suppose assume that it is not 3 by 2, assume. It is not 3 by 2. It is the m by n, assume. This one. N by p, assume. Then can you help me now? Then what is the answer? Answer is going to be, then time complexity is going to be big O of, what is the answer? 3 means m. Right? 4 means p. 2 means n. Right? Verify yourself. Suppose assume that all 3 are equal, then what is the answer? Right? Big O of n into n into n. Finally, big O of n cube. Big O of n cube. Right? If from today onwards, if anyone asks you, matrix multiplication will take time complexity n cube. Why? What is the answer? Matrix, right? C matrix contain n square elements. Suppose that, yeah, right? These all are equal. Assume that. I think here n square elements. C contain n square elements. Right? Next one. C contain n square elements. It's okay. Every element required n multiplications. Right? Finally, what is the answer? N square into n. Finally, n cube. Verify yourself. Normal numerical numbers I done first. Afterwards, I replaced corresponding values. Some people are asking, sir, what is this m and p? Right? Everyone. What is the answer? See this one. M by n, n by p. Right? So mp means these two. Into n means this one. Finally, if at all equal, order of n cube. Right? I think those people who are thinking a little bit doubt also. See the program, you know program for multiplication like this. For I is equal to 1 to n. For j is equal to 1 to n. For k is equal to 1 to n. One more loop. 3 loops required. Next one. Cij is equal to. See this one. Cij plus aik star bkj. Right, like this 3 loops are there. Please verify yourself. Initially Cij is 0. For each value Cij is 0. Cij is 0 for all. Right? For every I and j, Cij is 0. Right? Followed by this story. Right? I think 3 loops are there. N cube. Matrix multiplication time complexity n cube. Right? Please be careful. Now whatever is done until now, let me do once. See everyone. So can I have final conclusion? Matrix addition. If anyone having small confusion also, see this once. Matrix addition n square time because of 2 loops. Matrix multiplication n cube time complexity because of 3 loops. How 3 loops also roughly I explained to you. Right? So isn't that A m by n, B n by p, C contain m by p elements. Every element required n multiplication. Right? So one multiplication will take constant time. Finally, m into n into p multiplication will take constant. Finally, m and p time. If at all m is equal to n is equal to p, then order of n cube time. Multiplication is n cube time, addition is n square. If the given 2 matrices sizes are n by n. Right? Fine. And one more. Can you help me know what is our goal? Our goal is multiplication or addition? You only say. Our goal is, what is the topic name? Strassen's matrix multiplication is our topic name. This is our topic name. Strassen's matrix multiplication. If you want that, I have to explain matrix multiplication. I done both. It's okay. Now see, what is the interesting line? I am writing one more interesting line. Please see. I done the rhythm. Our goal is this only. Our goal is this one. Matrix multiplication only our goal. Because it's the Strassen's matrix multiplication. I done both, it's okay. See this one. I done both, it's okay. But one thing. I done both. See this one. I done both without, see this one. Without divide and conquer, I done both. Without divide and conquer, I done the addition also. I done multiplication also. Without divide and conquer, I done the addition also, I done multiplication also. Right? Please be careful. Now our goal is only matrix multiplication. Without divide and conquer, I done both. That's okay. Right? Our goal is matrix multiplication only, right? But with divide and conquer. Using divide and conquer, matrix multiplication will be done how? I will explain. This is not our goal. Only for namesake I explained. Without divide and conquer, I done the multiplication. Now with divide and conquer, I will do multiplication because the topic is that only. Right? See this one. Next application of divide and conquer is Strassen's matrix multiplication. Means matrix multiplication. Using divide and conquer, I should do. I done until now without divide and conquer. So that what I want to say. Only for namesake I explained. If I go directly, you may not know what is happening. Right? Addition I done. Multiplication also I done. Multiplication without divide and conquer I done. Now I will do multiplication with divide and conquer. Please careful. Please careful. Nothing there here. Please careful. So I am writing this. See everyone. With divide and conquer. Carefully listen. With divide and conquer. Matrix multiplication. With divide and conquer, matrix multiplication. So how it is? Carefully follow from now onwards. Until now whatever happened, it is really not required. You know very well. If anyone having small confusion until now, just remember. Matrix addition n square, matrix multiplication n cube, which you know very well. One contain 2 loops, one contain 3 loops. I want to say like this, but anyhow, rough idea I given. Now from now onwards you listen. With divide and conquer, matrix multiplication is how I will explain. It is going to be very difficult if you don't listen. If you listen, it is going to be very simple. So I am starting. So from now onwards, careful. See this one, A matrix. I will take A matrix 4 by 4. See from now onwards, careful I am explaining. See, A matrix is 4 by 4. B also 4 by 4. If you want to multiply two matrices, everyone know. First matrix number of columns, next matrix number of rows, both should be equal. But anyhow, I am taking square matrices so that no problem will be there. So A is 4 by 4, B is 4 by 4. These two matrices I want to multiply. See this one, my goal is this one, C is equal to A into B I want to do. If you want to do, what is the C size? C also becomes 4 by 4. Right? So I will write the C diagram also. See this one, C diagram. C is 4 by 4. See this one, C11, C12, C13, C14, C21, C22, C23, C24, C31, C32, C33, C34, C41, C42, C43, C44. Right? So I have two matrices A and B. A size is 4 by 4, B size also 4 by 4. C is equal to A into B is our goal. C also becomes 4 by 4. These are the elements. What is the C11 value? All the things I will explain. Can you help me now? What is the C size? N by N. So from these two, how to get this one, I will explain. Without divide and conquer, you know. That's what we explained until now. With divide and conquer, how it is the new thing? Please learn this also. Without divide and conquer, n cube, that procedure also you know. With divide and conquer, how will you do? With divide and conquer means what? Solving bigger one in terms of smaller one. How it is, right? I will explain. See, roughly let me write here. See this one. Roughly let me write. See everyone now, it is the A. I am giving normal way. See this one. A11, A12, A13, A14, A21, A22, A23, A24, A31, A32, A33, A34, A41, A42, A43, A44. Same way here. See this. B11, B12, B13, B14, B21, B22, B23, B24, B31, B32,
B33, B34. Next one, B41, 42, 43, 44. Right? It's okay, you know, normally in terms of B, right? Fine, that's okay. So, C is one, A contains 16 elements, 4 by 4. B also contains 16 elements, 4 by 4. C also same. I think everyone is fine now. Let me check. Let me ask you one small line now. How to get C11? Careful from now onwards. Until now, whatever happened, happened. Previous things, if you don't get also, no problem, because you know that very well. One is 2 loops, one is 3 loops. Please verify yourself. Now concentrate here. How to multiply two matrices with divide and conquer? See the topic name also. See the topic name also. With divide and conquer, matrix multiplication, how? Everything is ready. So, A is 4 by 4, B is 4 by 4, C is equal to A into B, C also 4 by 4. Right? N by N means what? 4 by 4. If you want, I will write. Right, fine. Can you help me out how to get the C11 without divide and conquer? You know, C11, what will you do? First row, first column multiply, you will get this. How to get the second one, right? I think first row, second column element, same. First row, second column multiply, you will get. You know that procedure very well. Now, using divide and conquer, how will you do? See the answer. Using divide and conquer, how will you do? I am explaining. See, please learn the new things. Using divide and conquer, how to get this one. So, this is the procedure. See everyone now, this is the procedure. Can you say, is it for divide and conquer means division should be there. Can you say, what is the size of this one? 4 by 4. This is also 4 by 4. Right? How to get the multiplication of these two using divide and conquer so that I will get this. How to get this? See, this is the answer. Interesting answer. See this one. Because of divide and conquer, careful listen. Because of divide and conquer, what will you do? See, for small problem, it's okay. See this one. Array size is 2 by 2 or less than or equal to 2 by 2, small problem. I am writing. It is not a big issue. That is the reason I didn't written until now. See this one. Array size is small when matrix multiplication is small when, right, matrices sizes are 2 by 2 or less than that. Less than or equal to 2 by 2. Matrices sizes are less than or equal to 2 by 2. 2 by 2 or less than or equal to 2 by 2. It is a small problem which will take constant time. Big problem means like this. Is it small problem or big problem? Big problem, because it is not 2 by 2, it is more than 2 by 2. So we have to apply divide and conquer means we have to divide. See how I am dividing. See everyone, everything is ready now. It is a big problem. Using divide and conquer I want to solve. So I have to divide. I am dividing. See, this is the way of division. Just go to the first matrix, 4 by 4, divide by 2. It became 2 by 2. Again this also divide by 2, it became 2 by 2. Some people are asking, what is the meaning of dividing by 2? What is the meaning? When you say divide and conquer, you have to divide. When you say divide by 2, it became 2 by 2. The meaning of this one is going to be, go to the first matrix, right? In the rows, middle draw one line. In columns also, middle draw one line. So if you want, you can check, it became 2 by 2. See this. So just go to, see this one, just go to, it is the 4 by 4 matrix. If you draw in middle line for both rows and column, it will become 2 by 2. That's what this line is. This also same, right? Middle row, middle column, draw one line. Middle row, middle column, just draw one line, right? So same way here also. That is the meaning of divide by 2. Right? So now all became 2 by 2. Please check. So if given matrices are 4 by 4, listen everyone now, if the given matrices are 4 by 4, if you divide by 2, they will become 2 by 2. See this one, it is a 2 by 2. It is also 2 by 2. If the given matrices are 8 by 8, if you divide by 2, they will become 4 by 4. Simple, whatever is there, if you draw middle line for the rows and column, they will become half. That's it. Right? Fine. I think everyone fine now. After division is over, carefully listen. After division is over, listen. After division is over, you have 2 by 2 matrices, it's okay. After division is over, you should do like this one. See everyone. Just make it, assume that everyone is one element. Forget about it is a matrix. Everyone is one element. Now, for the A matrix, right? This is the first element, A11. After division is over, consider this as one element. This also one element, A12. This also one element, A21. This also one more element, A22. Same thing here also. B11, B12, B21, B22, like that. Same. C11, C12, C21, C22.
Just divide by 2, it will become 2 by 2. So every element, every small matrix you consider it as this one. After division is over, every matrix you consider as one element. Now can you help you now? Now can you help you now? Forget about the actual size and after doing this much work, can you help you now? What is the A size? 2 by 2. Assume that this matrix is one element. So A 2 by 2. B also 2 by 2. C also 2 by 2. C is equal to A into B. Now can you help me once more if you are really okay? Right? A contain 4 elements, 2 rows, 2 column. B also 2 by 2, 2 rows, 2 columns. C also same. Now can you help me now? Can you help me? Interesting answer. Don't think that they are matrices. Don't think that. Assume that they are elements. You don't go inside, not required. What is the meaning of divide and conquer? What is the meaning of recursion? Solving bigger one in terms of smaller one. How you are doing, right, top level, if you know clearly, same thing will happen inside also. Some people are asking, sir, how they will be done, right? Whatever you done until now, for them also same thing will happen. Big problem, divide first by 2, right? Next one, after division is over, whatever you get, assume that everyone is one element. Afterwards, don't think inside, top level you see. When you do top level properly, right, inside properly will happen because same thing they will follow. Same thing will follow, right? Fine. I think until now everything is fine now. Now see this one. Don't think that inside some matrices are there. They are elements only. A is 2 by 2, B is 2 by 2, C is equal to A into B, C also becomes 2 by 2. Names also I given C11, C12 like that. Now see the answer. Because of everything all right. See this one. Can you help me now? Can you help me now? How to get C11? A is 2 by 2, B also 2 by 2, right? In the C matrix, how to get the, right, first row, first column, same thing. What will you do? First row, first column, multiply. What is the meaning? Can you multiply? First row, first column. In the first, see this one, in the A first row, in the B first column, multiply. Can you see how to multiply? A11 into B11 plus A12 into B21. Like that you multiply. See this one, first row, first column, multiply. You will get this same way. Can you see how to get the C12? How to get C12? C12, what is the first row, second column. First row, second column. Can you see how? Same thing. First row, second column, multiply. So what is the answer? A11 into B12 plus A12 into B22. Check if anything wrong. Right, go to the next one. In the C matrix, how to get the C21? Second row, first column. So what is the answer? A21 into B11 plus A22 into B21. Check if I am wrong. You everyone know this. Everyone know this. Only for namesake I am doing. See this one. C22. What is the answer? Second row, second column, multiply. A21 into B12 plus A22 into B22, right, like that. Fine, I hope everything fine now. So now see this one. Now see, interesting answer. Everything is ready. See the interesting answer. Make sure that I think until now everyone is fine now. See the interesting answer. Can you help me one small line now? A matrix size. A matrix, see this one. A11 size. Sorry for that. A11 size. How much? 2 by 2. Right? It is a 2 by 2. This is also 2 by 2. 2 by 2 matrices if you multiply, you will get it is a 2 by 2. It is also 2 by 2. 2 by 2 matrices if you multiply by 2 by 2 you will get it is also 2 by 2. It is also 2 by 2. If you multiply both of them 2 by 2. 2 by 2s if you add overall what will you get? 2 by 2 will get. Finally C11 is 2 by 2. What is the meaning? At a time 4 elements will come. At a time 4. Normally what we will do is, right, see this one, element compare. Now matrices you are comparing something like that. When you do without divide and conquer, one element you have to multiply. Now here what we do after division is over, right, matrices you are considering at one element, like that you are doing. See at a time 2, right, 2 by 2 matrix, 4 elements came. This also same thing, this also same thing, something like that. Right, now next one same thing here. What is the answer? This is going to be 2 by 2, this is 2 by 2. After multiplying 2 by 2, same thing here. 2 by 2. Overall becomes 2 by 2. C12 also 2 by 2. Like that it's keep on continuing. Right? I'm thinking you are absolutely fine now. Now if you are okay, can you help me now? Those people who got until now, what is the first step using divide and conquer? Take the matrices. Please check small or big. When small, 2 by 2 less than or equal to 2 by 2 small.
otherwise big. When it is big, what will you do? Divide by 2. What is the meaning of divide by 2? Rows also draw middle line, columns also draw middle line for the A and B. Now consider every one, even though they are matrices, consider every one is one element. Now A contain 2, A size becomes 2 by 2, B also becomes 2 by 2. If you multiply them, you will get the C, which is also 2 by 2. Right? So now every element is a matrix, may be inside. You don't bother what is inside and all. Right? Just follow now. After division is over, just follow normal way. Now it is interesting answer I want to ask you. Please listen. Please listen. See this one. Given problem if you observe. Given problem if you observe. 4 by 4 matrices you want to multiply. See this one. Given problem is 4 by 4 matrices you want to multiply. That is the given problem. 4 by 4 matrices you want to multiply. That is the actual problem. That one you are doing in terms of 2 by 2 matrices. See, these all are 2 by 2. 4 by 4 problem I am solving in terms of 2 by 2s. 4 by 4 matrix multiplication I am doing in terms of 2 by 2s. That is the meaning of divide and conquer. One more way I am saying. If these are 4 by 4, I am solving in terms of 2 by 2. See everyone is a 2 by 2. Please check. Next one. If these two are 8 by 8, careful listen. If these two are 8 by 8 matrices, I will solve all sub problems if you observe. All are 4 by 4. If the given problem is 4 by 4, I am doing in terms of 2 by 2. If the given problems are 8 by 8, I am solving these problems in terms of 4 by 4. If the given problems are 64 by 64, I will do these in terms of 32 by 32. Final thing, if the given two matrices are n by n, I will solve this n by n in terms of n by 2s. In terms of n by 2s. Please be careful. If they are 4 by 4, now see everyone 2 by 2. If they are 8 by 8, they will be 4 by 4. Some people are asking, sir, if they are 8 by 8, these all will be 4 by 4. Don't you divide? Recursion internally will divide, don't worry. How 4 by 4? Again big problem. Internally you will divide same way. 8 by 8 will be solved. 8 by 8 I will solve in terms of 4 by 4. 4 by 4 internally solve in terms of 2 by 2. But as a programmer, I will do only top level. As a programmer, I will do only top level. Right? Please be careful. I am thinking that you are absolutely fine here. If you are okay. Now see this one. If you want to multiply 4 by 4, if you want to multiply two 4 by 4 matrices, right, you should do this much work in terms of 2 by 2s. This much work means what is that? Let me calculate. This much work means what is that? I will calculate. See this one. Two 4 by 4 matrices if I want to multiply, right? See what I am doing in terms of 2 by 2s. Please see here. Given one is 4 by 4. If I want to do 4 by 4 matrix multiplication, I am doing in terms of 2 by 2. See how I am doing. Right? I think 2 by 2 matrix multiplication I should do here. 2 by 2 matrix multiplication I should do here. After getting both, 2 by 2 addition also I should do. Same thing. Right? 2 by 2 multiplication, 2 by 2 multiplication, 2 by 2 addition. Like that, see. Now can I help you now? If you want to multiply two matrices of size 4 by 4, you have to do in terms of 2 by 2, 8 matrix multiplication. Check. 1, 2, 3, 4, 5, 6, 7, 8. Next one, 4 additions you have to do. Right? Now if you are a little bit also okay, let me do here. See this one. Let me write. See this one. Let me write now. Listen interesting. See this one. One matrix multiplication. See this one. One matrix multiplication between two matrices of size 4 by 4. See this one. One matrix multiplication between two matrices of size 4 by 4 is equal to, see the answer, is equal to 8 matrix multiplication of size 2 by 2. One matrix multiplication between two matrices of size 4 by 4 is equal to 8 matrix multiplication of size 2 by 2 plus what is the answer? Plus what is the answer? 4 matrix additions of size 2 by 2. This is the work what you have to do. This one if you want to do in terms of divide and conquer, 8 matrix multiplication you have to do of size 2 by 2 plus 4 matrix additions of size 2 by 2. I am thinking you are little bit okay. See this also. Again, see this one. See everyone, one matrix multiplication if I want to do between two matrices of size 64 by 64 is equal to, see this one, is equal to 8 matrix multiplication, same story, 8 matrix multiplication of size 32 by 32. I am not saying 2 by 2. If you divide this one by 2, it will become 32.
So bigger problem in terms of smaller. How they will be done? They internally call, you don't bother. So 1 matrix multiplication of size 64 by 64 is equal to 8 matrix multiplication of size 32 by 32 plus what is the answer? 4 matrix additions of size 32 by 32. 32 by 32. I'm thinking you are okay with this also. See the last attempt. See the last attempt. See this one. 1 matrix multiplication of size n by n is equal to, what is the answer? 1 matrix multiplication of size n by n is equal to 8 matrix multiplications of size n by 2 plus 4 matrix additions of size n by 2. Right, this is. I'm thinking that everything absolutely fine. Now see the next story. See the next story. Listen, see the next story. See this one. Recurrence relation for a time I am writing. Recurrence relation for a time I am writing. Carefully listen. Recurrence relation for a time complexity. See this one. Tn is equal to, everyone listen. Tn is, before going to write the recurrence relation, I have to define what is the Tn. Tn is equal to time complexity or time of multiplying 2 matrices of size n by n using divide and conquer. Using divide and conquer or using divide and conquer algorithm. I will write. Roughly I written. Let me read once again. Tn is equal to time of multiplying 2 matrices of size n by n using divide and conquer algorithm. Right? Whatever we discussed, that algorithm name is divide and conquer algorithm. Tn is equal to time of multiplying 2 matrices of size n by n using divide and conquer algorithm. Right? If you are okay, see the recurrence relation. You know very well that recurrence relation. Let me write. Tn is equal to, what is the answer? Constant time. When? If n is, right, less than or equal to 2. Right? Multiplying 2 matrices of size n by n, time complexity using this algorithm Tn is equal to order of 1 if size is less than or equal to 2 by 2. 2 means less than or equal to 2 by 2. Now see this one. If big problem, see the interesting answer. If big problem, see this one. 1 matrix multiplication of size n by n, it is a big problem. In terms of small you have to do. Then what is the answer? 8 matrix multiplication of size n by 2. I written already, check. 1 matrix multiplication of size n by n if you want to do. 8 matrix multiplication of size n by 2. Right. Plus, see the interesting answer. Plus, how many additions? 4 additions I have to do. Of size 8 matrix multiplications of size n by 2 plus 4 addition. Can you help me know what is the Tn? Tn is, see this one, interesting. This is the very difficult one if you don't listen. Tn is the 2 n by n matrices to multiply time complexity Tn. This one, Tn is the time complexity to multiply 2 matrices of size n by n. It is the matrix. Tn is going to be matrix multiplication story. See this one. N by n size matrix multiplication you are doing in terms of n by 2 matrix. T means multiplication. See, it is a recursive call. Big multiplication in terms of small multiplication. But one thing, it is not recursion because it is addition. Big multiplication in terms of small multiplication, right? That is called as recursion. N by n matrix multiplication I am doing in terms of n by 2 matrix multiplication. So recursion there. But it is not a recursion because it is addition. It is addition. Can I say 4 additions of size how much? N by 2. See this one. 4 additions of size n by 2. Now you please give answer. Because of it is not a recursive one, it is not a recursion, so you can use. It is a recursion, please be careful. Big multiplication in terms of small multiplication. It is a addition, no relation at all. 4 additions of size n by 2. Now can you help me now? That is the reason I explained this one. Can you help me now this line? See everyone now. 1 addition, see this one. Addition time complexity. Matrix addition time complexity. Matrix addition of size n by n. How much time? N square. N by n matrices to add time complexity n square. N by n matrices to add time complexity n square. Please be careful. If you are okay, now come to our answer. See our answer. So 4 additions of size n by 2. 1 addition of size n by n is n square. 4 additions of size n by 2 is going to be
right? N by 2 whole square. One addition is going to be of size n by n, n by 2 whole square, like that 4 times. If n is, right, greater than or equal to 2 by, greater than 2 by 2. So Tn is equal to order of 1 if n is less than or equal to 2 by 2, otherwise 8Tn by 2 plus 4 additions of size n by 2. One addition of size n by 2 is n by 2 whole square, like that 4 times. If you simplify roughly, see this one, if you simplify roughly, Tn is equal to 8Tn by 2 plus 4 into n square by 4. What is the answer? N square. It is the recurrence relation. Now see this one. From today onwards, if anyone asks you, matrix multiplication of size n by n using divide and conquer, what will be the recurrence relation? This is the recurrence relation. 8Tn by 2 plus n square. How it came? Right? From here. How it came? From this story. See this. Clearly explained with a numerical example. See these all. Please try to get. You may say that, sir, how it came? Right? Like this. Like this it came. Right? Some people are asking, big multiplication in terms of small multiplication, why don't you do for this also recursion? See this one, always remember, multiplication only, recursion going on. How addition also? At a time, one story. If you want to do addition for the purpose of recursion and all, you can do that. But here matrix multiplication is going on. Big multiplication in terms of small multiplication, it is a non-recursion. One addition of size n by n is n square, right? One addition of size n by 2 is n by 2 whole square, like that 4 times, right? Tn is equal to 8Tn by 2 plus n square. Please be careful. Next one, if you solve this one using substitution method, log n times, if you do approximately, you will get answer as, right? See this one, you will get answer as, right? 8 power log n base 2 you will get, which will goes to, why this base 2? Always dividing by 2 by 2 by 2. You will get this much answer. Finally, n power log 8 base 2 you will get, which will become big O of n cube. Means what I want to say, with divide and conquer also same time complexity, without divide and conquer also same time complexity. Please be careful. With divide and conquer also same time. See, with divide and conquer n cube, without divide and conquer also we done. Without divide and conquer already there, right? See, without divide and conquer already there. So this one, n cube. With divide and conquer also n cube. Without divide and conquer also n cube. But one thing, what is the answer? Because it is a non-recursive program, stack not required. Here stack required. Because it is a recursive program, stack required. See, this log n stack required, time complexity n cube. Both will take same time complexity, but if you see the space, because it is a recursion, log n stack space required, that is not required stack space. That is not required stack space. Right? Fine. Stack space is log n. And one more thing, see, stack space is log n, it's okay, but to keep the result, one more matrix C required. Two matrices both you are multiplying, that's fine. To keep the result, one more C matrix required. There also required, here also required. But I am talking about stack. Their stack space order of 1 because of non-recursion. It is going to be stack space is log n. Now, can you help from now onwards, if anyone asks you, matrix multiplication without divide and conquer n cube. With divide and conquer, same n cube. But here stack size log n required, there is no stack size there, order of 1. But one thing, there also extra space if you talk. After multiplying both the matrices, C matrix you have to store. C matrix required, there also extra. Here also C matrix. But stack there constant, here it is going to be log n. Right? Fine. So, with maximum they will ask you, see this one, maximum they will ask you, with divide and conquer to multiply two matrices, what will be the recurrence relation? This one you remember. Now, let's come to the one more interesting answer. Can you help How many matrix multiplications are required? 8 matrix multiplication of size n by 2, it's okay. Plus 4 additions of size n by 2. Please be careful. Plus 4 additions of size n by 2. Now, listen everyone. Listen everyone now. There is one Russian mathematician, his name is Trashans. There is one Russian mathematician, his name is Trashans. What he done is, he done almost like 10 years of research he done. Finally, what he done is, using divide and conquer, multiplying two matrices will take time complexity 8Tn by 2 plus n square. Right? That is the previous result what is available. What Trashans done on that? 10 years of rigorous research and all, finally concluded like this one. See this one. Time complexity of multiplying two matrices of size n by n
right, is equal to order of 1 if n is less than or equal to, if n is less than or equal to, let me write. If n is less than or equal to 2 by 2, that's okay. Right, T of n is equal to constant, if n is less than or equal to 2 by 2, I am okay. Next one, if it is big, see what happened. There 80n by 2 plus n square, but he done like this one, 70n by 2 square. 70n by 2. There here 8 multiplications are required, but he made it as only 7. Means what the meaning? Matrix multiplications he decreased. Here 8 matrix multiplication of size n by 2. He done only 7 matrix multiplication of size n by 2. Because of matrix multiplications he decreased, additions are increased. It became, right, 18 additions of size n by 2. Multiplications decrease, additions are increased if n is greater than 2 by 2. According to Strassen's. If you simplify this one, see this one, if you simplify this one, it will become Tn is equal to 70n by 2 plus, what is the answer? I think 18 by 4. How much? 4, 4, 16, 2, 4, 5s. 4.5 n square. But anyhow, that is a constant. 70n by 2 plus n square. If you want, you can keep that constant also. There is no problem. You solve same answer, you will get 70n by 2 plus n square. This answer becomes, right, like this. See this one, this answer becomes 7 power log n base 2 you will get, which will become n power log 7 base 2 you will get, which is become big O of n power 2.81 you will get. So, matrix multiplication according to Strassen's answer is going to be n power 2.81. Please be careful. According to Strassen's, he done, right, he done really extraordinary hard work. He made 8 matrix multiplication as 7. Because of multiplications decreased, additions increased. He got to know that additions you can take a little bit extra also. Multiplications if you can decrease, right, this problem can be solved. He proved like that. Finally, right, this is the thing. They will ask you in the exam, according to Strassen's, what is the matrix multiplication, according to Strassen's, what will be the time complexity to multiply 2 matrices? This is the answer. What will be the recurrence relation, right? So, maybe this will be there in the option. Some constant into n square, which is nothing but n square. This one you remember, this one you remember. How it came, if you want, you can see in the book also, right? Strassen's proved that this recurrence relation will be converted into like this, which will be finally converted into like this. If you solve it, n power 2.81. Some people are asking me, so what improvement he done, right? Before Strassen's, everyone thinking that multiplying 2 matrices compulsory required 3 for loops. He proved that 2 end of for loop is enough almost. 2.81. Without Strassen's, everyone thinking that multiplying 2 matrices compulsory 3 full for loops required. He proved that 2 end of for loop is more than enough. Exactly, Strassen's and divide and conquer almost same, one line you write. Can you help According to divide and conquer, what is the answer? 80n by 2 plus n square. Just replace 8 by 7. Just replace, forget about this one. Just replace same recurrence relation, replace 8 by 7, right? Then finally you will get this answer. Can you help Divide and conquer recurrence relation. What is the answer for matrix multiple 80n by 2 plus n square? Just replace 8 by 7, 70n by 2 plus n square. This is for Strassen's, this is for divide and conquer. It will give n cube, it will give n power 2.81. Right? Without divide and conquer, what is the answer? Without divide and conquer, n cube. So, it don't require stack, means constant stack space required. Here log n stack space, here also log n stack space. Here log n stack space, here constant stack space, here log n stack space. Fine, okay, whatever you got, fine. Now I explained these many things. See this one. I explained these many things. Without divide and conquer matrix addition, matrix multiplication. Next one. With divide and conquer matrix multiplication, because our goal is matrix multiplication only. After doing with divide and conquer matrix multiplication, I got answer as n cube because recurrence relation 80n by 2 plus n square. Right? But Strassen's done lot of research and he proved that in the place of 8 multiplication, we can take 7. Right? If you now recurrence will become 70n by 2 plus n square. Previously 80n by 2, now 70n by 2. If you solve it, n power 2.81 will come. So, it is an unimaginary thing. Everyone thought that less than 3 for loops, no chance. He proved that less than 3 for loops is possible. right? Fine. And one more thing, see, one more thing. Please be careful. Both the reconciliations you remember, time complexity you remember. In the previous paper, right, one question also not came from this. Actually, I don't want to say, just I given rough diagram. It is more than enough. This one is more than enough. If you read this one, more than enough. Please be careful. So, can you help in what are the applications I said until now? First application, finding max min. Second, power of an element. Third, binary search. Fourth, merge sort. Fifth, quick sort. Right? I think until now. Next one. Sixth, selection procedure. Seventh, Strasson's matrix multiplication. 7 applications I said. Without by hearting, please study. And one more, some people are asking how 8 becomes 7, it decreases the multiplication, increases the addition, how they increased. If you want proof and all, you open any book, you will get, just write one line, Strasson's matrix multiplication. I want to say that also really not required. One also not came in the previous paper, right? If I write everything, you will keep on reading. It is not one person, you only, right? Many people will do, unnecessarily I am wasting their time, right? Those people who are interested, proof also, please go through it. 8 becomes 7, how? Right? 4 additions becomes 18 additions, how? Just I think almost like, right? 10 equations are there. Please go through it. Right? So, whatever necessary, I am keeping in your notes. 7 applications I said, you please take care. I want to give homework to you. Right? Because I said 7 applications. I want to give some work to you. That is the reason I written all. See this one. Homework or room work or whatever it may be, I don't know, right? So I want to give some work so that you can verify, you can do some work, right? See what happened. First application, first work maybe 1. Applications of divide and conquer only, you can try how it is going on. See this first one. Continuous maximum subarray sum. You just Google it out, you will get this problem. Continuous maximum subarray sum. Right? This is the one application, right, which you have to do homework by yourself. Right? So just Google it out. In the YouTube also there. In Google also there. Please, you will find out the answer. Using divide and conquer you can do. Next one. See the second one. Finding closest pair in the given area of n points in xy plane. This is also well known problem. Right? In YouTube there is one nice video. Right? Please go through it. Using divide and conquer you can solve. Finding closest pair in the given area of n points in xy plane. This also you have to take care. 3. See the 3. 3 is very small problem. See the 3. In the given area of n elements in which until some position all elements are in increasing order and afterwards all are in decreasing order. Means one array there where, right, in the given array there is one array which contains n elements. There is one array which contains n elements. In this array, all elements are in increasing order until some place and afterwards decreasing order. Until here increasing order, from here decreasing order. Now, right, decreasing order. Then what will be the time complexity to find position of first element in decreasing order? What will be the time complexity to find position of first element in decreasing order? It is increasing order, it is decreasing order. In the decreasing order first element, this position you have to return. What is the time complexity? These are the 3 problems I am giving to you homework. I explained 7 applications. I am giving 3 things similar to those. One is continuous maximum subarray sum. It is there in the Coreman book also. They solved also. Please see. Next one, finding closest pair in the xy plane. It is a well-known problem of computer science. Please go through this also. This is a very simple problem, easily you can do. Right? Binary search possible, please verify. To this problem, binary search possible. Right? These 3 problems. So, those 7 problems plus these 3 problems. If you can do these 10 problems combinedly without by hearting meaningfully, what is the meaning of divide and conquer? In every problem you have to verify this only, right? So divide time how much? How to do divide? What is the time? What is the conquer? What is the combine? In all these problems, please verify like that. Okay, to this problem, this is the way division, right? Most of the divisions are blind divisions, right? Few divisions are meaningful divisions. But when you divide blindly, maybe combine difficult. So these 10 applications without by hearting, please do
right? Followed by. In the previous papers, if anything there, those also do. Don't refer some other books and all. They if you solve in one subject, one chapter, these many. What about other subjects? For the divide and conquer, these 10 problems are enough without by hearting. Right? I'm thinking you are okay. So, divide and conquer, 7 applications I done, 3 applications I given the homework to you, 10 is more than enough. Now what I will do is, right, because of now you are absolutely fine, it's the correct time to give few problems of time complexity of recursive program. Previously I done some problems, right? Now I want to give few more which are left out. Let me do that also. It is very easy now. To you it is very easy, right? Let me try this. Let me try one problem. See this one? Time complexity you have to find out. Time complexity. Time complexity you have to find out. I am giving few problems. Almost you are okay, right? So I am thinking that 1 or 2 lines are missing. I want to cover those. Please see. Algorithm name is A of n. If n is less than or equal to 1, return n square plus n plus 10, that is okay. Else return, see this one, else return, see everyone now, else return (3a n by 2) plus 5a n by 2 plus 3a n by 2 plus 5a n by 2 plus, see this one, plus, see this one, matrix addition, it is the matrix addition, please be careful, you know that algorithm very well. I am not writing that algorithm because you know that algorithm. Matrix addition of size n by n. Matrix addition of size n by n. See this one, A of n. If n less than or equal to 1, return this. Else, return 3an by 2 plus 5an by 2 plus matrix addition of size n by n. Matrix addition, you know that algorithm. There is a algorithm also, right? Matrix addition of size n by n. 2 for loops are there inside. 2 for loops are there, 2 inner loop. It will take n square time, you know this very well. Now they are asking, to this problem time complexity find out. To this recursive program, find time complexity. Can you say, how will you find time complexity? That 1 or 2 small problems are pending. That is the reason I am covering here. It is the correct time to do this. To this recursive program, find time complexity. And one more thing, matrix addition of n, it is a one function. Please be careful. Like merge algorithm, like partition algorithm, one algorithm here. When you say algorithm, there is a code. See, code is there. Because of you know that code, I didn't return. Right? This matrix addition will take time complexity n square. 2 loops are there. 2 loops. 2 inner loops are there. 2 inner loops. Time complexity n square, that is fine. Now can you help me now? How to find out this recursive program time complexity? You know very well. How? Let me write. Tn is equal to small problem constant, that's okay. Here no loop, nothing there. See this constant. Order of 1 time. If n less than or equal to 1, that's fine. Can you help me now? Big problem. Big problem, how much time? Recursive program, if you want to find out time complexity, write the reconciliation and solve it. Right? I'm doing. So small problem, constant time. See the big problem. See this one. An will take Tn. See everyone now. An will take Tn. That's okay. Now can you help me now? An will take Tn. That is fine. Now what is this one? 3an by 2. You always remember. Time complexity means function calls loops. Time complexity means function calls and loops. Can you help me now? Recursion is recursion. An Tn. See this one. An Tn. An by 2. What is the answer? Tn by 2. Time complexity means, right? Recursion is recursion. Next one is going to be, after recursions are over, next one is loop, right? See this one, I think here nowhere loop, but here loop is there. Here loop not there directly, indirectly. What is the meaning of indirectly? Here function name, if I go there, there is a loop. Time complexity means recursion is recursion. That one I cannot remove, right? So an is Tn, an by 2, Tn by 2, that is fine. Next one is going to be loops directly, indirectly. What is the meaning of indirectly? Function call, if I go there, there is a loop. Or otherwise directly loop, that is also okay. Can you help me now? An by 2, Tn by 2, this also.
an by 2. What is the answer? Tn by 2. That is also. Some people are asking, sir, it is not, right? An by 2, Tn by 2. It is 3Tn by 2. No. Here 3 function calls are not there. Here 3 function calls are not there. One function call, after getting this answer, multiply by 3. See this one, an by 2, an by 2, an by 2. If I write 3 times in the program, if I write 3 times, then only 3Tn by 2. Into 3, everyone know, can you help me now? Into 3, if anyone say 3, right? 3an by 2 is 3Tn by 2. If anyone say like that, please be careful. Please be careful. It cannot be, right? It cannot be. Please be careful. Until unless I will write 3 times an by 2 function call 3 times, then only write 3Tn by 2. It's a time complexity. If anyone thinking that, sir, I will write as it is reconciliation, if you do that, right, 3an by 2 is there, if you write 3Tn by 2, if you write, that is not time complexity, that is a value. As it is, if you write, that is value. Time complexity means function calls how many? How many function call? Here one function call, think about only function call. Function call Tn by 2, function call Tn by 2, remaining constant, into, after getting this function call answer, into 3, what is there in that? Next one, this is going to be into 5, what is there in that? Initially, see this one, I think when I am saying the recursive program time complexity, one problem also I given, see I given one problem, see this one, I given one problem, n into f of n minus 1, I given one problem also. That time itself I said, what is the time complexity for this? Tn minus 1, that afterwards into n, I don't bother into n something like that, because loops only will take time complexity, into n, this is constant. This will take Tn minus 1, it's okay. Because of into n, I cannot write, n into I cannot write. So loops only will take time complexity, there is no loop, see this one. This will take Tn by 2, right? Here there is no loop, constant. Just multiplying will take constant, right? Next one. If anyone says, if 3 is there, if I write 3, here n square is there, then you have to write n square. Please be careful. Loops only will take time complexity. Recursion is recursion, fine. But here after getting this one, into 3 means constant you have to take. If anyone want to take directly, then why don't you take here n square directly? Please be careful. So only concentrated function calls. Only concentrated function call. Okay, an Tn, an by 2 Tn by 2, an by 2 Tn by 2. Next one, is there any loops? 2 recursive calls only there. So 2Tn by 2 will come, it's okay. Next one, is there any loops further? No. Here indirectly loop is there. How much? N square. Now if you see finally, what is the answer? Right? This will take constant. Right? This will take constant n square. Finally, what is the answer? Tn by 2 plus c. One more Tn by 2 plus c plus n square. If n is greater than 1. Right? If you simplify roughly, what is the answer? Tn is equal to 2Tn by 2 plus n square. If you solve this one, big O of n square, right? Please you take care. If anyone thinking that, sir, I done some mistake, right? If anyone thinking that, sir, I done some mistake, I written the 3Tn by 2. If anyone thinking like that, because of that reason I said this problem. If anyone I written the 3Tn by 2, if anyone say like that, then in this problem, right? Initially we done, please check. Right? n into f of n minus 1. In this problem, if you observe, f of n minus 1 is the t of n minus 1. Afterwards, no loop is there. Loop means for loop required. For loop required. Right? So, no loop is there. So, n into doesn't mean that I cannot write n into. Right? Remaining thing is constant. So, to this one, what is the answer? It is there in your notes also, please check. Tn minus 1 plus c. n into means I cannot write n into Tn minus 1. Please be careful. See this one, when you say time complexity, okay, a and Tn, here is there any a, okay, Tn by 2, okay, Tn by 2, remaining things you don't see, right? Function calls you have to see and loops you have to see. I think there is no loop in this area. an by 2, Tn by 2, an by 2, Tn by 2, no loop in this area. Small constant, it's okay. But here function call it is. Some people are asking, sir, how can you say function call? There is a code. There is a code. Please go there and check, okay, n square, just write n square. If suppose using that function call is not there, function call is there normal, so constant. Right? Constant. Now go to the next one. One more problem. So what is the answer of this problem finally? N square. What is the topic name? Time complexity finding of this program. Some people are asking, then why are you given? Previously time complexity finding of recursive program. Few I given. There I forgotten. So just I am saying here. Please check. Any small mistake also, please take care. See this also. One more problem. Time complexity finding. See this also. Small mistake you may do wrong. Please see this also. A of n. If n less than or equal to 1, return n square, else return an by 2 into an by 2 minus an by 2 plus n cube. Right, end of this. Time complexity finding, right? So see this program. An, if n less than or equal to 1, return n square, else return an by 2 into an by 2 minus an by 2 plus n cube. What is the time complexity? See the answer. You know answer very well. See the answer of this. Tn is equal to constant time. If n less than or equal to 1, that's okay. Now come to the else part. Big problem. Then what is the answer? It is a constant. Because of n square, I don't write n square. Some people are asking, sir, n square is there, I will write n square. If n square is there, I will write n square. Someone saying, you can write. If they are asking value, this recurrence relation will give what value? N less than or equal to 1, return n square. As it is, if you write, that is value. Time complexity means loops. Is there any loop here? No, constant. Now come to the else part. Right? So recursion is recursion. We cannot do anything in that. An, what is the time? Tn. Next one, an by 2. What is the time? Tn. An by 2, Tn by 2. An by 2, Tn by 2. An by 2, Tn by 2. So, see, recursion is recursion. An, Tn. An by 2, Tn by 2. Like that I done. Fine. After doing all recursive calls are completed, now see, in the remaining, is there any loops? See, nowhere loop is there. Is it addition or multiplication or division? I don't care. Right? Recursion is recursion. Afterwards, any loop. You may say that, sir, n cube. N cube doesn't mean that I will take n cube. N cube means, right? If you want to say time complexity n cube, 3 inner loops required. No loop is there. So, all 3. What is the answer? 3t n by 2. Remaining no loop is there, constant. If n is greater than 1. So, finally, this recurrence relation, if you solve using master theorem, right? So, you can do whatever way you want. So, what is the answer? This one, 3t n by 2 plus c, right? Using master theorem, you can solve. What is the f of n? C. What is the n power log a base b? Which will become n power log 3 base 2. Which will become, right? Log 3 base 3 is 1. Log 3 base 2. What is the n power? 1.5. Right? Log 3 base 2. 1.5, something like that. Right? So, finally, what is the answer? This person is bigger by, right? Polynomial. It is a constant, it is a polynomial time bigger. Answer is going to be theta of n power log 3 base 2. If it is not there in the option, maybe you can take this. So, the answer of this problem is n power log 3 base 2, it will be the recurrence relation. You may be thinking that minus also will take constant, multiplication also will take constant, division also will take constant. So, loops only will take time complexity. Recursion is recursion, no doubt. Remaining, is there any loop or not? Check. See, n cube doesn't mean that n cube. 3 inner loops should be there, then n cube. Otherwise, in the place of n cube, matrix multiplication there, using divide and conquer or normal, whatever it may be, then maybe n cube. But one thing, loops only will take time. No loop is there. See, no loop. If anyone said the matrix multiplication, where is the code? Right? Fine. Anyhow, no loop is there. Remaining is constant. So, if you solve this one using master theorem or substitution method, answer is n power log 3 base 2. Right? This is the divide and conquer ending. You please see all of them. Many things I said to you, starting to ending, please check. So, see, these are the topics. See, these are topic wise you study. Right? First one, time complexity finding. Next one, asymptotic notation. Right? Next one, recurrence relation solving. Next one, right? Finding max min, quick sort, merge sort. Please study topic wise. Any topic, any question is not okay. Ask your friends, ask me, right? Please do 99% work from your side. Don't ask anyone blindly. Don't depend on anyone, right?